Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 3, the 4th edition RK Bali navigation book. So let's start with question number 61. At any given weight or altitude, so whatever the weight of aircraft, light weight, medium weight, heavy weight, altitude, you are flying from sea level, 5,000 feet, 10,000 feet, whatever that is, whatever density altitude, aircraft will always lift off at the same calibrated airspeed, true airspeed, ground speed. So the correct answer is option alpha. You will find this takeoff calibrated airspeed in your POH manuals. So if it states that aircraft takes off at 55 knots, let's say, so whatever day, whatever density altitude, whatever weight of your aircraft, it will take off at same 55 knots indicated airspeed or 55 knots calibrated airspeed. Now let's say you're flying from a very high density altitude, it's a very hot day, and the density altitude is much more than the pressure altitude. So if density altitude is more than pressure altitude because of the hotness, what will happen is that the true airspeed that you will require, the actual speed of your aircraft that you will require to achieve that 55 knots calibrated airspeed, which is your takeoff speed or lift-off speed, will the demand of it will be more. The ground speed will be more. Okay. So aircraft will take off at same calibrated airspeed, but the speed, the time that you will take of the time that you will need to accelerate your aircraft up to that airspeed will vary. So true airspeed can vary. The ground speed will also vary depending on headwind, tailwind, crosswind, whatever. Okay, so depending on your density altitude, the true airspeed of your aircraft will vary. Okay, if the density altitude is very high, you will require very long amount of runway, great acceleration to go up to 55 knots lift-off speed. If the density altitude is very low or is equal to your pressure altitude or even lower than your pressure altitude, the true airspeed required to accelerate and achieve the 55 knots lift-off speed will be much less. Okay, so the time will differ, but the calibrated airspeed at which you will lift off or leave the ground surface will remain the same. So alpha is the correct answer. Question number 62. Velocity maximum operating is the speed expressed in terms of CAS, computed airspeed, calibrated airspeed. So it is expressed in terms of calibrated airspeed. So VMO is nothing but your VNE, never exceed speed. But for large jet aircraft, you have VMO, you don't have VNE, you have velocity maximum operating speed. Next. The limits of the white scale of an airspeed indicator are what? Now your airspeed indicator will have different colors. Okay, especially your general aviation aircraft, they have different colors. For example, white color is for white arc, green arc, yellow, and the red color. So the white arc represents flap operating speed. Okay, so white arc represents the flap operating range. Okay, so if you want to deploy your flaps, that means if you want to operate your flaps or use your flaps for landing configuration to bring your aircraft into landing configuration, you can use them or you can deploy them only and only when your aircraft speed is in the white arc, somewhere in the white arc, not necessarily one particular value, but somewhere in the white arc. Now this white arc starts from VSO. What is VSO? VSO is the stall speed of your aircraft in when your aircraft is in landing configuration. That means landing gear retracted, flaps retracted, okay, landing gear configuration. The upper limit or the maximum limit of the white arc is VFE, which is your flap extension speed. The maximum speed at which you can extend your flaps, okay, extend. Okay, so previously I said landing configuration is where landing gear is retracted. That's wrong. Landing configuration is when the landing gear is extended. It's used. Okay, it's taken out of the belly of your aircraft, and similarly flaps are extended or used for landing purpose. So flap extension speed, the maximum speed at which you can extend your flaps to bring your aircraft into landing configuration. So that is your white arc, mainly for flap speeds. Next is the green arc. Now this green arc is nothing but normal operating speeds. When you are flying in the green arc, you are flying in normal operating speeds or normal operating range. Okay, so the lower limit of this green arc is Vs1, which is the stall speed of your aircraft in clean configuration. That means you are not using landing gear, you have retracted them after takeoff, and you have retracted the takeoff flap setting. So this is stall speed in clean configuration, and the maximum limit of the green arc is VNO, which is the maximum normal operating speed. Now if you want to exceed this maximum normal operating speed and you want to fly in the yellow arc, this yellow arc, you can do that only and only in still air. So that is, this yellow arc is nothing but cautionary speed range, and you can fly in that yellow arc speeds only in still atmosphere. Next, the last red color line is the never exceed speed. You cannot exceed that speed. That is the maximum threshold. So, coming back to the question, the limits of the white scale of an ASI are VS1 for the lower limit, VFE for the upper limit, VSO for the lower limit, VNE for the upper limit, VSO for the lower limit, and VFE for the upper limit. So white arc is VSO for the lower limit and VFE for the upper limit. So correct answer is option Charlie, VSO for the lower limit and VFE flap extension speed for the upper limit. What is the local speed of sound at 30,000 feet if ambient temperature is minus 40 degrees Celsius? So you can find this out using CH3. I will show you another way using a formula. Local speed of sound is 39.17 square root of temperature in terms of Kelvin. Now minus 40 degrees Celsius is minus 40 plus 273, that is 233 Kelvin. So 39.17 square root of 233 Kelvin is 597.9 or 598 knots. So the closest option is option A. Okay, so 233 Kelvin, option A, 594. So at 30,000 feet, if temperature is minus 40 degrees Celsius, it's very cold, you will achieve a local speed of sound attain the speed of sound at 594 knots. Okay, next. The indications on a Mach meter are independent of what? So Mach meter or Mach number is stats upon local speed of sound. Now this Mach number is nothing but, this Mach meter indication is nothing but a ratio of dynamic pressure and static pressure. Dynamic pressure and static pressure. Dynamic pressure is total pressure minus static pressure, that gives which is dynamic pressure divided by static pressure. So it is independent of dynamic pressure, no. Independent of static pressure, no. It is independent of ambient temperature. How will Mach meter respond in a constant Mach number climb if the static source becomes blocked? Okay, so static port is blocked. That means there is no way outside static pressure, the mean static pressure can enter your Mach meter instrument. So let's consider an illustration, an example. So you are climbing at constant Mach number, right? So let's say this is the air mass in which you are climbing. Okay, so climbing at a constant Mach number. So you are climbing at constant Mach number. So the static pressure at this altitude is, let's say, static pressure, let's say 800 millibar. You want to go to a higher altitude somewhere here. So as you go to higher altitude, static pressure decreases. So static pressure here is, let's say, 400 millibars. 400 millibars. Now Mach number here is what? Let's say dynamic pressure divided by static pressure. What is static pressure? It is 800. It is 800, right? And dynamic pressure, whatever the dynamic pressure of your aircraft, you can write it here. Let's say dynamic pressure is 1600. So Mach number will be 2, 2.0. Now, what happens when you go to higher altitude? Static pressure decreases. So Mach number should be dynamic divided by static. Now, in order to have a constant Mach number, because it's a Mach number flying constant, dynamic pressure should be 2 equals to d divided by 400, which is equal to 800. Okay, so dynamic pressure should be 800. Okay, at lower altitudes, dynamic pressure we considered 1600. When you go to higher altitude, the dynamic pressure requirement is now less, 800. 800 dynamic pressure and static pressure 400 can also give you same Mach number. But since the static port is blocked, so this 400 millibar outside static pressure cannot enter your Mach meter instrument. And we all know that Mach meter is nothing but dynamic pressure divided by static pressure. So if this new static pressure cannot enter your Mach meter instrument, so what will happen? The reading of the Mach number or Mach meter will get affected. Or okay, so outside this is the ideal situation that I have explained. This is what should happen. But if the static port is blocked, that means the previous static pressure. Let's say your static port got blocked at this particular altitude. Let's say this altitude is 5000 feet. So what will happen in its journey to go to 10,000 feet? The static port got blocked at 5000 feet. So whatever static pressure at 5000 feet, that particular static pressure will get or will remain trapped in the Mach meter instrument. Okay, there will be no way through which outside new static pressure like 400 millibar can enter the Mach meter. Blockage happen at 5000 feet, the pressure at that 5000 feet will remain trapped in the instrument. So what will be a new calculation? So according to this, a new calculation will be Mach number equals to dynamic pressure. What is dynamic pressure? 800 divided by static pressure 800. So what will happen? Mach number equals to 1.0. Okay, it should be 2. Mach number should be 2, and for that dynamic pressure should be 800, right? And static pressure should be 400. Only and only that we can climb at a constant Mach number of 2.0. But since a static port is blocked, so the old static pressure will be registered, will remain under registration, and a final calculation will be dynamic divided by static 1. So what has happened to the Mach meter indication? It has decreased. From 2, it has become 1. So the correct answer is, how will Mach meter respond in a constant Mach number climb if the static source becomes blocked? So the Mach number indication will decrease. You will be flying at a constant Mach number of 2.0. That's fine. But since the static port is blocked, the indication given to you will be a lesser one. Indications of the DGI when used as an onboard instrument are valid for only a short period. The causes of this inaccuracy or the causes of this drawback are Earth's rotation, yes. Longitudinal acceleration, no. Aircraft's motion over the surface of the Earth, yes. Mechanical defects of the gyro, yes. Gyro's weight, no. The gimbal's mount of the gyro rings. So the correct answer here is Earth's rotation, the aircraft's motion over the surface of the Earth, the mechanical defects of the gyro. So options 1, 3 and 4. What could be the indication on an attitude indicator in a right turn? So whenever you enter a right turn or a left turn, always artificial horizon will indicate a false pitch up attitude. Even if you're making a straight and level right turn, the tendency of the artificial horizon will be to indicate a climb or pitch up attitude. So that is the false information given. So it will be climb due to pendulous vanes, no climb descent. So correct answer is option alpha. So remember this. When you are turning 90 degree, you are making a 90-degree left turn, right turn, whatever, pitch error, climb. You are making a 180-degree turn, pitch error, again climb. You are making 270-degree turn, pitch error, climb. And you are making a full 360-degree turn, only and only then the pitch angle at the end of your turn will be correct. But otherwise, it will be a climbing turn. Okay, so initially it will start making a climbing turn. Okay, the indication, you may be flying straight, it will be a turn, level turn, but still the indication given by the artificial horizon will be a climbing one. Next, very important about bank angle. So along with a wrong or false attitude indication, the artificial horizon will also give wrong or false bank indication. So a turn through 90-degree, in that case bank angle will be under red. Turn through 180-degree, bank angle will be correct. Turn through 270-degree, the bank angle will be over red. And turn through 360-degree, bank angle will be correct. So what will a classic artificial horizon indicate when turning through 90 degrees at constant attitude and constant bank angle? So even after maintaining a constant attitude and angle, the artificial horizon will falsely indicate a bank angle which is less than the one you have established and a pitch attitude of a climbing pitch attitude. Okay. So correct bank angle, correct attitude, no. Too little bank angle, that means under reading, yes. Too much nose up attitude, yes. Too little bank angle and too little nose up attitude, wrong. So the correct answer will be option Bravo. Too little bank under reading and too much nose up attitude. Classic artificial horizon indications turning through 180-degree at constant bank angle. So constant bank angle turning through 180-degree, bank angle indication will be correct, but the pitch indication will be a climbing one. So nose up, angle of bank too low, wrong. Nose up, angle of bank high, wrong. Nose up, yes. Correct angle of bank, yes. So option Charlie is the correct answer. So memorize these 4 points and that will be sufficient. So this ends a lecture. I hope you have understood all the 10 questions that I have answered in this video lecture, especially the constant Mach number climbing one. Okay, so there are many such situations in which you're climbing at constant Mach number, static port block, climbing at constant CAS, what happens to through speed and all those similar questions. So you have to watch all my video lectures in which I have solved all the sample questions from the sample papers. I have solved many Keith William questions, RK Bali questions. And in those video lectures, I remember there have been many questions similar to this constant Mach number climb question. Okay, so when you do watch those video lectures, solve those questions, you will be able to answer this questions like this uh, conceptually, understanding the concept behind them, and then answering with a valid reason. Okay, instead of just memorizing, because there is too much to memorize. So it's wise to understand the concept, the explanation, the why and how of everything, and then come up with your own solution. So no shortcuts to success. So do watch those video lectures. There are many, and I wish you all the best. Keep working hard, keep practicing, be consistent. And if you have any doubts or questions, let me know in the comment box. See you in my next video lecture.